right. So our answer is infinity. We say when an object is placed at f of a convex lens, the location of the image formed is at infinity. Then the next question says a lens that is thinner at the middle and thicker at the edge is what type of lens? I just drew the two lenses for you now. What kind of lens is that?
Um,
The one that is
um,
thinner
I'll
at the
reread all of
middle.
these things.
Sylvester, pay attention. We just did it.
I
There's
know
no
now.
time.
You will no time for what?
Do you have much time to cover all this thing? Why not grab the much you can grab
Yes,
now
I
so
do.
that what you will read will
I'm
be small?
grabbing now.
So I just drew two lenses for you now. Why can't you answer from the two lenses I drew for you now? What's the answer? A lens that is thinner at the middle and thicker at the edges is what? Is it diverging lens? Is it converging lens? Is it plano convex? Is it converging?
Diverging lens.
And you say you don't know.
I thought you meant like the name, like all of those, concave,
We're answering
um,
question and you are saying all of those
biconcave.
are for you.
So that's the one you're talking about.
The image formed by a diverging lens is always dash. Diverging lens is always dash. What's the answer?
Always virtual and erect.
Virtual erect and what?
Diminished and enlarged.
Sylvester, Mark Pugisio. I go break your head though. You see, this is a diverging lens. You have the focus to be somewhere here, and then you have the optical center here. If you place the object anywhere here, irrespective of the position of the object, the image formed is always virtual, erect, and diminished. Diminished. So the ray that is the divergent ray, if you trace it back, this divergent ray now, if you trace it back, it will look as if it originates from this point. You see, it look as if it originates from this point. Meanwhile, it's a ray that diverged when it hits the lens. So another ray will pass through the optical center undeviated. Any ray that whether convex lens, concave lens, any ray that passes through the optical center will pass through undeviated to go like a straight line. So where these two rays meet is where the image is formed. So this is where the diminished image is formed. This is the image. So irrespective of where this object is, if this object is even placed somewhere around here, if the object is placed somewhere around here, you will still get the image diminished. And the image will always be formed between C and F. And then the human eye, anybody that is viewing it, will see a diminished image. Do you understand?
Yes.
All right. Now, so our answer is virtual, virtual, erect, and diminished. Now, the next question here, I'll just be the ones I feel like you can complete. I'll just give you the formula. An object is placed 20 cm in front of a converging lens. So I already treated all the cases. So I told you that each question points at one of those cases. So your ability to know which case a given question is pointing at or is directed towards or is ascribed to, your ability to identify that, you are one step getting to the answer, right? Or one step to the answer. Now, this is 20 cm. Assuming the object is here. Let's say the focal length is, this is the focus. So from here, from the optical center, here is 15. That's the focal length. Now, the object is placed 20 cm. You see, the object is placed 20 cm. So from here to here is 20. So you see that this case now is pointing at when an object is, because twice this distance, this is where you will have your 2f somewhere around here. So from here to here will be 30. So you see that if the object is placed 20 cm from the lens, that means the object is placed between f and 2f, or f prime and 2f prime, depending. Then this other side will be your f, and equally here will be your 2f. So if you draw this, and then this passes through f, like this, and then the other passes through c, if you do it very well. You see, and the other one passes through C, like this. You see, you will get an enlarged image. You will get an enlarged real image. Sylvester, do you follow?
Yes.
So now, because you know that the image is real, then you're going to use this formula, 1 all over f equal to 1 all over u plus 1 over v. If you picture the case and it happens to be that the object is placed between C and F, that means the object distance will be less than the focal length. Then in that case, this place will turn to negative because the image formed will be a negative, will be a virtual image. So you change here to negative. Do you understand? But if it is for this, if it is for the diverging lens that we just did, there is always, because they tell you that the image formed by a diverging lens is always virtual, erect, and diminished. That means you're going to always use this formula, minus 1 over f equal to 1 all over u minus 1 over v. This minus happens to be here because the focal length, the focus of a diverging lens is virtual, or it has a false focus. That's what we call it. So that's why we'll attach negative to it. Then this second negative is because the image is always virtual. But see here, you see that the ray truly passed through what? F. So this one has a true focus. That's why we don't put negative here rather than positive. Do you understand? Then whether this will change to positive, will be positive or change to negative, is if the image is real or virtual. If the image is real, then here will be positive. Here is always positive, whether the image is real or not, because this one has to do with the focal length of the lens. And the focal length of the lens, of the focus of the lens, is true focus. So this one is always positive for a converging lens or a convex lens. But here will be positive if the image is real, and here will be negative if the image is virtual. You need to know these things. If you don't know it, you might solve some problem, get it right, and some get it wrong. Do you understand? Because maybe you misinterpreted it. Now, having known this, you can easily find your V. I believe you can easily find your V. You plug in your focal length, plug in your focal length here, plug in your object distance, and then find this. I believe you can do that. All right. Now, the next question says, Sylvester, are you following?
Yes.
The next question says, which of the following characteristics of light determines its color? That is wavelength. We don't need to go much into that. In We have different colors have their different wavelengths. So we know that the white light has 7 colors, right? So these colors, as they are splitted on the spectrum, they're splitted according to their wavelength. So the wavelength of a given uh, light tells you which color that light is. Do you understand what I mean? Whether it is red,
Yes.
orange, yellow, green, and all that. Now, the next question says that a converging lens, you see, we have a converging lens again. A converging lens, you see, 10 focal length 10 cm, forms an erect image. Did you see now? They've given you
Yes.
a clue. Did you see? An erect image forms an erect image 3 times the size of a real object. Calculate the distance between the object and the image. So another thing you need to also know that if an object is real for a converging lens, if an object is real for a converging lens, that the distance between the object and the image you're going to add. You're going to add because if this is a converging lens, for instance, and the image is real, just like the one we just drew now, you see that the object is upright here and the image is inverted somewhere here. So from here to here will give you, from here to here will give you the V, which is the image distance. While from here to here will give you the U, which is the object distance. So the distance between the image, the object and the image is what? V plus U. But you see, when the image is erect, when the image is erect, you see, there's only one case when the image is erect, which is the case where the object is placed between the focus and the optical center. So if this is the focus and this is the optical center of the lens, and the object is placed somewhere around here. So you see that the image formed, the image formed, sorry, let me use. So you see, the image formed will always be what? Because this side, there's no way these two rays can meet. You see, these two rays can never meet. These two rays, they can never meet. Because if you keep drawing them, they will keep widening up, keep opening up. So you're gonna trace the rays backwards. You trace the rays backwards, you see. So where these two rays meet is where the image is formed. So this is the virtual image that is formed. You can see that the virtual image that is formed is, it can be 3 times, it can be 2 times the size of the object. But the point is that it is bigger than the object. It is enlarged. All right. So now we know you're going to use this formula 1 all over what? F equal to 1 over U minus, because you already know the image is erect. You already know that the image is uh, virtual. So you're going to use the one with minus. Now, what are you going to do? You plug in your focal length here. Then this problem, you already have one value. You plug in a vocal length here, which is 10. Then you can suspend this here and then go and find the relationship between the image size and the object size, which you get from the what? The magnification. So magnification is V over U. Do you understand? So the image is magnified 3 times the size of it. So the magnification of the image is 3. So you can see that V is equal to what? 3U. So you can bring in that U here. Sylvester, are you following? You can come in here and then you have your what? 3U. So the LCM is what? 3U. So U divide U is 3. 3 times 1, 3. Minus 3U divide 3U. 1. 1 times 1, 1. Then you will have what? 2 over 3U. Do you follow? Equal
Yes.
to 1 over 10. So you are now going to multiply, cross multiply. You have 20. So you now have that 3U is equal to 20. So here now you see that 3U is equal to 20. That means V is 20. This now. Meanwhile, U will be what? 20 over 3. So this is 20 cm. This will be 20 over 3 cm. So you can now come, because this is the distance of the object to the lens, which is U. And this from here to the lens again is V, the distance of the image to the lens. So you see, for you to find the distance between this, if this is D, which is the distance between the object and the image, that means it will be V minus U. Do you understand what I've been telling you? Because the image and the object are formed on the same side of the lens, that means the distance between the image and the object will be what? D minus U. Do you follow, Sylvester?
Yes.
So it will be V minus U. So it will be V minus U. So the distance will be V minus U. All right. So in that case, you will do 20 minus 20 over 3. I believe you can solve this from here and get your answer, your D. All right. Sylvester, do you follow?
Yes.
No, go tomorrow. Don't go to the exam hall and mess up. Oh. If you go to the exam hall and mess up and see all these things you are solving and you still mess up, I will not be happy with you. Chineke benigwa amarakwala. Now we have that diverging lens. You see another trigger, diverging lens. Did you see now? Without being told, I already told you that once you see diverging lens, we're talking about concave lens, and you have to just quickly write down the formula. Minus, because diverging lens has a false focus, so you have to put minus. Equal to, is not always, don't just use 1 over f equal to 1 over u, because you know this is the general formula. You have to design it to suit the question. You put minus here, then 1 all over u, minus again 1 over v. So this is the formula you're going to use. Now, if you use this formula, you just get your answer direct. So you have minus 1 over 30 equal to 1 over u. Because you are determining the object distance, so 1 over u, your u is the object distance. Then minus 1 over v, which is the image distance. That is what? 20. Then you throw minus. I notice that you always careless. When you are throwing your value to the other side, sometimes you forget to change the sign, and it will affect your final answer, definitely. So you have 1 all over u equal to, you have to be very careful in this exam, boy. Don't mess up. 1 all over 2, 20, I mean. This plus, this minus 1 over 20 has been thrown to this side. So it changes to plus. Then we have minus 1 over 30 as it is. Then you now find the LCM, which is 60. Then this will give you 3. Write 3 here. This will give you 2. So you have 1 over what? 60. So without being told, U is equal to 60. Sylvester, do you follow?
Yes.
So U is equal to 60, which is option D. Now, at what position will an object be placed in
So
front
it's okay
of,
now.
what's that?
So it's not only physics I have to
What do you
know.
have tomorrow?
I need to go and read computer.
Okay, you are telling me it's okay. You that have an exam tomorrow. You don't want to. See, we have a
So
lot
how
to
will I read
cover.
computer?
Okay, you are telling me you want to read computer.
I will also read physics. And when I'm done, I'll brush through these past questions.
So how would you know the answer?
I'll solve them now.
You will solve them.
Yes.
You know how to solve them.
Yes.
Anyway, some of the questions here, I can see which of the following is not application of echo. You see, I have already answered some of these
So I
questions.
was the answer for that number 5.
Which of the following is not an application of echo? Detection of submarine, detection of a characteristics of sound. This one, determination of characteristics of sound. Because determination of speed of sound in air is also uh, the application. Exploration for oil and gas is also the application. But the determination of the characteristics of sound is not the application of echo. The pitch can be increasing the frequency. Increasing the frequency, this is the answer. This one, the amplitude of a sound determines its loudness. Ah, Sylvester, you are dulling my spirits. One night, a night.
I need to read other things.
All right, boy. The property of an eye with power of accommodation, ciliary muscle. Please pay attention. Lack of an use is to hardening and the onset of old age. Did you see? Onset of old age. Presbyopia. Onset of old age. Hardening of eye lens and usually onset of old age. The use of lens is not applicable in which one? Look at the answer. Periscope.
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 It uses mirrors now in
Mm-hmm.
Periscope.
Uses mirror. So I guess that okay, look at that one. That one will answer the other side that doesn't have options. Presbyopia is a defect of the eye resulting from see weak ciliary muscle. The devices use lenses in the operation except okay, periscope. At what position will an object place in convex in order to obtain an image at infinity? It must be placed at the principal focus. We even answered that question somewhere. Okay. You see, so we don't have really have much that you worry your head about. See, I've answered almost all the questions here. The frequency column decreases. The frequency increases. If you remember, we have F varies as 1 over L. So if this decreases, this will increase. Inversely proportional. That's the law, if you remember. Now, the last question will solve maybe the last question, maybe not. The beats period. You see the difference. Beats, sounds that are two sounds that sound at very close frequencies. They are called beats. So what's the beat period? The beat period. So you just find the beat frequency. You subtract 12 minus 10. Sylvester, are you following?
Yes.
That's 2 hairs. Then the period, bit period. That's 1 over f, which is 1 over 2. And 1 over 2 is 0.5. All right, so I guess other questions, remember the formula to use when it comes to echo V equal to 2D over T. Don't forget the formula. Look at this one. Power. All right, so we're going to stop here. I believe all the things here, vibration of air column, which of the following instrument produce sound by vibration of air column? That is flute. Okay? Which of these is a wing instrument? Wing instrument. Sylvester, wing instrument. Sylvester,
The guitar. Oh,
guitar.
it's a wind instrument. So
Mm,
it's an organ.
okay. All right, so we are gonna. Oh, there are other questions here. Did you people do electricity? Hmm?
No, you
Did you
said
people
that it's
do?
not set to those ones. This is not just.
Did you people do gravitational uh,
No, no, I don't know if we
force
didn't.
of gravity? Huh? Newton's law
No,
of gravitational. Okay. Escape velocity and all that. You people didn't do it.
no.
Okay. That means we are done. All right. I wish you good luck in your exam. See you in our next class. Bye bye. Yeah. Today we had today I had class with Sylvester. Sylvester is a secondary school student in Stella Maris. Um, over the years now, I've been the one teaching him from primary school until now. He's in SS2. So today he's preparing for his internal school exam, second term exam on physics. So I decided to record this. So for reference purposes. All right. So uh, if you are new in my channel, you do well to subscribe. If you're a regular, you are welcome. Thank you for subscribing. With all that being said, I'll see you in my next video. Thank you.